Okay, today we're going to go through Chapter 5 problems. Some of them will be how to do for loop, how to do while loop, how to build and construct kind of a pyramid and design certain formatting through using these loops. So the first one we're going to do is 511 here. Find a number divisible by 5 or 6, but not both. If you remember, that symbol is the square root. And so we will be using the modulo 5 equals 0, square root modulo 6 equals 0. So you're going to write a program that displays all the numbers from 0 to 200. So you know your condition. In your for loop, that first line will be if number is equal, number will start at 100 and until it's less than or equal to 200. And then it 10 numbers per line. So we're going to need to find a way to use, we're going to use a modulo to do 10 numbers per line. And then they're divisible by 5 or 6, but not both. Numbers are separated by exactly one space. So one of the great pages that you're going to need to remember is 147. That is Chapter 4, one of the big formatting parts of Chapter 4. It's one of the only things that are really, really necessary for Chapter 5 by doing Chapter 4 first. Otherwise, you can kind of do either chapter, whichever order you want. So this is the one we're going to use first. It'll output a string with width at least whatever number is right here. And so let's go back to 193 is, I believe, 511. Yeah. Okay, so let's get started. We will open 511. We need to have a for loop that says int I equals 100 to start. I, when I is less than or equal to 200, since it's starting at 100, we can just put while I is less than or equal to 200, and then we're going to I plus plus each time. And what are we trying to find? Well, we're trying to see if I is divisible by 5 equals 0, or 6 but not both. So that would be the square where the square root comes in. Modulo 6 equals 0. Okay. And you set up our brackets. So if this is true, we're going to system.out.print, and we're going to need to do that specific formatting. So you're going to do a printf, not a print line, and you're going to do a %, the number of spaces, and then s. So we're going to test 3 and make sure that works, but that's what we're going to do. And then you need to have a comma for what you're going to print next. And so the formatting comes in the first slot before the comma, and then after the comma, that's what you're going to be printing. Okay? So if I ran that now, that would give me 100, 102, 105. Okay, so not exactly what I want, but it's printing all the numbers. Now if I put a space here, this is closer to what I want. So one space in between. I know it's going to be a 3-digit number because it's between 100 and 200. So now I have all these numbers in one long line, but I want them to not be in a long line. So if I no, we can't use I because I is going to not be the same every time you add a new number in. This is just going to be one of these numbers up here. We need to create a new variable that does our counting. So I'm just going to do int count equals 0. Actually, we'll start count at 1. That'll be a little bit better for us. So first we got to add, each time a number goes in, we'll add the count. So if count modulo 10 equals 0, if you think about it, what does this do? It sees if count is divisible by 10, so it'll print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we need to do something. That something that we're going to do is system.out.print line, and we're just going to print a space, but it ends the line. So now there is an error. Okay. Why would there be an error? 1, 2, 3, 4, 5, 6, 7, 8, 9. I need to have 10. So maybe I do start this at 0. Okay, so there's still a space here. The count needs to be outside of the if statement because this is only counting if it's a number that is, excuse me, this needs to be inside of this if statement here. So if it runs right here, then we have them lined up nice and pretty. So that we have our formatting correct. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A new line, 10 more. A new line, 10 more. Okay. Make sure I get all my everything lined up. Okay. All right. So that will be 511. Now 513. We have find the largest n such that n to the third is less than 12,000. So we know that's going to be the big condition, while n to the third is less than 12,000. And we will use a while loop. So we can have int n equals 0, start off, while n is less than 12,000. Set up our loop. We are seeing if n times n times n is less than 12,000. So n times n times n is less than 12,000. While that is true, we are going to n plus plus. Okay. And then we will exit the loop when n is greater than 12,000 or equal to 12,000. Well, n to the third is greater than or equal to 12,000. So we need to then print system.out.print line. We can start off with n space plus. So this number, whatever it is, where's my caret? There it is. To the third is the largest number less than 12,000. Largest number for, I'm going to make this nice and pretty, plus n plus that is less than 12,000. Okay, see how that looks. Make sure it's working correctly. Okay, 23 to the third is the largest number for 23 that is less than 12,000. But can anyone see why this would be an issue and this would be incorrect? So when you're doing and this is checking to see if this is less than 12,000, but then once it's inside, it'll add one more to it. So we're going to need to do n minus 1 and n minus 1 to counteract that plus plus that happens inside. So we need to make sure that that is known, that that is an equation, and that this is an equation. Let's double check. And 22 to the third. And so you can double check that by doing 22 times 22 times 22. I believe it's around 10,000. And 23 to the third is around 12,500, 12,500, somewhere around there. So that is correct, and that is what we're looking for. Okay. All right, going forward, 519. Let's take a look. These are some of the more difficult ones here. Okay. So 519 is asking that we display this entire pattern. Okay. Now, if you notice, 518 might be one that you want to do first to get yourself ready for 519. But if you're able to do 519, you definitely can do 518 as well. So what we're going to need to do is we're going to need to create a loop that has 1, 2, 3, 4, 5, 6, 7, 8 rows. And then within that loop, we are going to build this portion of the pyramid and this portion of the pyramid. Okay, and so we're going to need to first be able to create these blanks, these blanks, these blanks, these blanks, these numbers, all of these numbers, and then the blanks afterwards, and so on and so forth. Okay, so let's go ahead and get started. We're going to start off with int number. And we can just set that to 0 for now. This will be the numbers that we actually place in there. And then we want our row. And since we know how many rows we're going to have, we're going to do a for loop equals 0. Row, we want 8 total. So less than or equal to 7. And then row plus plus. Now, this is just setting up our rows. Okay, so I'm going to do that. Setting up our rows. Okay, and then within that, we need to do our columns, our columns on the left side. Okay, so for int column equals 1. Since we're counting the columns, we can start with 1. Column less than or equal to, and we want the columns to be. Remember, these are counting our spaces, so it needs to be on row 1. We want all but 1 space. Row 2, row 3, we want less and less spaces. So we need to have our total number of columns, which will be 7, minus the number of the number that row is, so that we have the further down, when we get to row 8, we shouldn't have any spaces in front of the columns. If you guys go back and look at this, row 1 should have this many spaces, so you're going to do, there's going to be -1 from it, and then -2, 3, 4, 5, 6, 7, 8, and so there should be no spaces on this one. Okay, so that is how this will work. So column plus plus. and then we want to have a certain width available, and so our width should be 1, 2, 3, 4 total. And so we can do our formatting that we did on the first problem. Printf, same thing, percent for s, comma, and since we are setting up our blanks right now, like I said before, we just want a blank there. Okay. Now we're going to be setting up our actual numbers. So maybe it'll look a little nicer if I put my comment up here. And I'm going to have setting up blank in columns. Okay. Setting up numbers is what we're going to be doing next for int column, because we are putting our numbers in based off of the column number that we're at. So column equals 0. So since our blanks start right here, our blanks go all the way to here, we're going to start with 1. But since our numbers start right here, we're going to go with 0. Okay, so that's our column starting with 0. Okay, column, and we're going to do the number of numbers we're going to put is the same number of rows that we're going to have in there. So we're going to have it's going to correlate with the row that we're on. Okay, and then column's going to go up each time. Okay, so our number, if you notice, write a nested for loop that prints the following output. Okay, our numbers are multiples of 2. You have realized that. Should have. Okay, so all multiples of 2. So we're going to need to do a math.pow. So number equals, we want them to be integers. Dot pow 2, comma. So 2 is our root number, column is our exponent. So column starts at 0, correct? So 2 to the 0 will print our 1. Okay? And then 2 to the 1 will print our 2. And since this loop is happening, the number of rows that we have, so until column is less than or equal to rows, okay, this will print, row will be 0 the first time through this loop, and column will be 0. So math.pow 2 to the column equals 0. So that'll print the 1 here. And then the next time through the loop, row will be 1. So column equals 0. Column's less than or equal to 1. It'll print 2. Column will be, the second time through the loop, it'll be 1. And so that'll print your 2. Okay? And then so on and so forth. Third time through the loop, through the outer loop, row will be 2, column will be 0. It'll do 0. It'll print the number. That'll be 1. And then it'll be 1. It'll print the number. And then it'll be 2. So 2 times 2 is 4. That'll be the third time through the loop. So that would be right here. 1, 2, third time through the loop. Okay? We need to then print that and print it the way we want it. And since this is a number, if we go back to page 147, output the integer item with width at least 5, output the string with width at least 12. So that's the difference between the two. When I'm doing spaces, I use S, but when I'm using an integer, I'll use D. So that's something that you're just going to have to memorize. But that would be 4D because that's the size we want, comma, number, right? That's what we're wanting to print. Okay, and it's not going to be line, it's going to be F. Okay, now we run it. I misspelled math. Okay, simple as that. Okay, so does this look somewhat what we want? In a way, yes. So at the end, we're going to print line, and that will print, and it'll make it to a new line, and it'll be outside all of these rows. So I'm actually going to do that. I'm just going to do that now and kind of test where I'm at and make sure we're on the right schedule here. So look at what I've created. Just like I was saying, you print the pads first, or excuse me, the spaces first, and then we're going to print these numbers here. So if we go back to 194, okay, I have printed pattern C essentially, okay, but I've just used a different number. So I've printed this right here. Now we're just going to have to change things up a little bit to do the right half. And if you want to challenge yourself, you might want to pause or hide my screen if you're here with me and try to do this on your own without my help, since you know how to do the left side. See if you can do the right side. A little bit reverse, a little bit of things that are changed, but pretty similar. So we know we're going to need a for loop that is going to be the right half of the rows. And actually, once you do the right half, you're not even going to have to setting up numbers for right half, setting up numbers for left half. Okay. For loop. All right, so what do we want now that we know? Now that we know what our with our column at 0, okay, we need to find a way so that our column can extend even further. So this is what we did. We subtracted row with column going all the way up to 7 right here. And then for our numbers, we had column starting at 0, column less than or equal to row, column plus plus. Now to get the other side, we can do our column equals row minus 1 to start off. So at row 0, we're going to see if we don't want anything to show up on row 0, right? So the way we can check if it's at row 0 is we can do row minus 1 for column, and then column has to be greater than or equal to 0. Okay? And then we never want that to show up. So we know in this situation, we're going the left side, so our column was going up greater and greater and greater. We were adding to this column, adding to this column, adding to this column. Well, now we're going to be going away and falling down, and so we want our column to be doing that as well, so we're going to be minus minus. Okay, and so now when row, the second time through the loop, row will be 1. Row 1 minus 1 equals 0, so that will be successful, but we don't want it to happen again, so we did column minus minus. Okay, so you can copy and paste this same code, because we're printing essentially the same thing. And so if you look through this, column at column 2, or excuse me, row 2. Okay? So when row is at row, well, this would actually be row 1, but row 2 right here. Okay, so row 2, 2 minus 1 equals 1. So column will equal 1, and it will run this and print a number. So it'll print 2 to the power of 1, so it'll print 2 after it right here. And then column will minus minus. Column will go from 1 to 0 the second time through the loop, because it minus minus is at the end. And now 0 is greater than or equal to 0. Yes, that's true. So 2 to the 0, it would print a 2 and then a 1. Does everyone understand that? And then as you go further, row is now 1 more, so it'll print 4, 2, and then 1. And it'll complete our pyramid. Does that make sense? Everybody get that? Okay. Might be something you have to go over more than once and really read through the code. I would recommend going over each particular part, okay, and really trying to figure out each loop in and of itself and how it relates to the outer loop. So this nested loop gets very complex, but look at the comments, look at each loop, and try to read it and try to figure out what each one of them does. Okay. All right. Our last problem here, 525. It is asking us to, it's similar to the other problem, it's computing pi, but we're going to compute pi 10,000 times and doing the equation 20,000 times and 100,000 times. Now, this I think makes things more confusing. You just need to realize you're going to do 4 times 1 minus 1 over 3 plus 1 over 5 minus 1 over 7. And that's going to go up incrementally, and it's going to go up incrementally 10,000 times, 20,000 times, 100,000 times. Okay, so we know we are going to need to create this loop. Okay, so int I equals 0 to start off. So we can do that as a for loop. For int I equals 0. Int I is less than or equal to 10,000 to start. Actually 100,000, because that's going to be our biggest value. Int I, not int I keep doing int I plus plus. Go ahead and fix that for me. I just need I. Okay. Now, we have our equation that we need to do. So we're going to need to have a value for pi, because we don't know what pi is right now. So pi, is it going to be an int or a double? Double. Yeah, thank you, class. Pi equals, just set it to 0 for now, or 1 for now. It's fine. Okay, pi equals 4 times now we're going to have a variable for sine because we're adding and then subtracting and then adding and subtracting. So int sine, I'm going to start it with -1, -1. Okay. So then we're going to do 1 sine 1 actually, I'm going to start it with +1. Okay, sine's going to be positive, and we're going to do sine over I is going to start off at 1. We're going to change that. Sine divided by 2 times I minus 1.0. Okay, so by doing that, we are actually multiplying by 4, and actually that's not 4 is not going to be repeated, so I'm going to have to edit that. Sometimes you need to just read through the code, guys. Even I mess up, okay, while I'm doing this. So this is what's getting repeated, okay?
Please come to the main gym during Tiger Pods to play spikeball to support girls tennis for the chance to win a Quick Trip gift card. Thank you.
So this equation is what's happening inside of these parentheses, and that's what's happening over and over and over again. We're timesing by 4 at the end, so we are gonna. This needs to get added over and over because every time we're adding -1/3, +1/5, -1/7, and I keeps adding up. So what's I times 2? Well, it's 2. -1 is 1. So the first time you just have 1. Then the second time through the loop, I is 2. 2 times 2 is 4. -1 is 3. Here's our third. And then we're going to also have to do every time sign needs to switch. So we're going to do sign equals negative sign. So every time it switches. And then we're going to system.out.print line. We'll just do pi times 4, and we'll see what that prints for now. See how close we are. Okay, we're a little bit off. We're only we're gonna make sign negative before. So since we're starting at 1 and then subtracting, we need to start this at 2 and be on our first multiplication right here. That should print out pi times 4. Then if we run that, that will equal close to pi, as close as you can get. going up to here. But then we need to do an if statement. If, and it says for 10,000, 20,000, 30, 40, 50, 60, all the way up to 100. So if I modulo 10,000 equals 0, we are going to cut, paste. This is just for good measure. You don't have to have, with a one-line if statement, one line in your command, you don't have to have parentheses, but I like to use them anyways. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so that would work from 10,000 to all the way including 100,000. So that will be your answer for problem exercise 525. Thanks for watching.